In problem A, we have a block of mass 100 kilograms being pulled across a surface by a pulling force P with a magnitude of 400 newtons. We're also given the coefficient of friction between the block and the surface. Now, first things first, let's draw a free body diagram of the system. So here we have the block. We always start with the mass, it's the easiest one. So the weight of this is 100, the mass, multiplied by acceleration due to gravity. And we have a reaction force R opposing it, which is the ground pushing against the block basically. We also have a pulling force P, we have magnitude of 400, and we have friction force opposing the motion. Friction force is equal to mu times the reaction force. That's friction force. And the block is moving in the right direction, like so. And it's accelerating, it's getting faster. So this is the direction of the acceleration. Now, we will go ahead and state two modeling assumptions. So the first assumption is that the block is modeled as a particle. So it has no dimensions. You can see we don't have the length of the block, we don't care. Second of all, we're going to assume that the acceleration is constant. And the reason we're doing that is because we can see the forward force is fixed, the friction force is also fixed, so therefore you're going to have a fixed difference between these two. The number's not going to change. So the speed is going to increase linearly in a constant manner. Now, let's find the acceleration of the wooden sledge, which is the next part. So, even if we don't look for acceleration, we can always model the system, and that will give us acceleration. And the way we model systems is we're going to use the sum of forces is equal to ma. This means all the forces added together in the x direction is equal to mass times acceleration, with the direction of motion being positive. It's moving to the right, so right forces are positive. So this one's positive and this one's negative. So 400 minus mu r is equal to ma. M, the mass is 100, multiplied by the acceleration. This here is the sum of forces. Now we need to find r, so we can substitute into this equation. We already have mu is 0.2 given here. But to find r, we simply look in the y direction. Now this block is not moving up and down, that means it's balanced in the y direction. It means up equals down. So from this picture we can clearly see r is equal to 100 g. R is not always equal to mg. Sometimes you have other forces here, so you have to do up equals down and make r the subject. But here, there's only two forces, so this must equal this. Plug this into here, along with the coefficient of friction, and we get 400 minus 0.2. Another way of writing 0.2 in fraction form is 1 over 5. So I'm going to use the fraction form, it's just easier. R is 100g, we've already said that. You can see we can divide these straight away. That's why I put it in fraction form. Equals 100a. Now, once we process this, here you're going to get 100 divided by 5, which is 20. So it's 400 minus 20g equals 100a. Find this number, then divide both sides by 100. And in the end, you will get an acceleration equal to 2.038 meters per second squared.